Lecture 9, Module 1, DMAIC, Improved Stage Part 2, Assessing the Risks. In this module, we'll look at assessing risks using graphs, fishbone diagrams, process capability analysis, and FMEAs. During the improve phase, potential solutions are proposed, developed, evaluated, and then implemented. But before implementation, there should be an evaluation of the risk involved with the proposed solutions. It would be foolhardy to blindly implement a solution only to find that it made matters worse. Therefore, some degree of risk assessment should be carried out first. If any risks are identified, some remediation may be required prior to implementation. In addition, no team, no matter how well trained or experienced, can develop a solution that is completely free of unseen issues and problems. Consequently, solutions really should be implemented in a test environment, such as a pilot or sandbox project at the start. Graphing, as always, is used to help visualize what you are working with or dealing with. It's important to capture a picture of the state of the process before and after the changes you're making. A targeted review of all graphs created in the earlier stages should be performed. Create new fishbone diagrams for the proposed process to look for new inputs and potential risks from them. Process capability charts should be created to look for risks also. And run charts of the new process should be reviewed to look for risks. Fishbone diagrams are great ways to quickly visualize your process and identify potential risks, and can be quickly created using inexpensive and readily available software packages. For instance, the diagram below was created fairly rapidly in Visio. There are other types of programs out there that are free that you can easily download from the internet. Statistical process control, or SPC, is the monitoring and controlling of a process to ensure that it produces product within its specifications. A central concept of SPC is that every measurable process has a statistical distribution, and therefore a sample of the process can observe the effects of common causes on its central tendency, what we call the mean, and its dispersion, what we also call the standard deviation. Through the use of SPC, a process can predictably produce product on target, conforming to specifications, and creating the least amount of waste. The next two process capability charts show us two different processes and show us their different conformance to the target, comparing the CP and the CPK, conformance to the specifications, CPK and the parts per million, and the risk of future failures, the parts per million. These values can be used to assess the relative risks posed by our process, new or old. So here we see a process for a 100 milligram tablet batch data that is off target. It is not centered, obviously, and is a high risk for producing future defects. The CP does not equal the CPK, meaning it's off target, and the parts per million is high. This process, with a lower standard deviation, less dispersion, is also not centered, but is not a high risk for future defects. The CP does not equal CPK, but the parts per million is very low. So simply having the CP not equal the CPK is not cause for alarm. It's cause for maybe corrections, but it's not cause for alarm or a high risk. Run charts should be reviewed to identify the relative risk posed by our process. Just how confident are we in the stability and dependability of our process? By collecting data, we can look for possible problems coming down the road. FMEA. The original FMEA of the process should be revisited with the previous information in hand and the changes from the chosen solutions assessed as to whether the risk should have been reduced and if any new risks have been created. Note, all FMEAs are performed in two steps, two stages. There's always a pre-FMEA where the FMEA is first performed, and then subsequently after that another FMEA is performed on the same process, or a post-FMEA. So here's our FMEA example from Lecture 6, where we looked at the terminal sterilization and actually at the final sterilization of some pre-filled syringes. And we've looked at three different instances of potential failures, and we found their severities, their probabilities, and detectability, calculated their RPNs and the criticalities, and used this for prioritizing our work. Well, now it's time to update this risk assessment. Part of the original FMEA is to indicate how the decisions on the rankings in the risk assessment were arrived at. You may have noticed that the chart has changed because off to the right are these other columns where more information will be added. Now this is the document in the description of the risk analysis column. The risk analysis indicates possible frequency of occurrence and the ability for detection also. Next, the solutions decided upon based on the risk analysis need to be documented in the recommended actions column. Once again, no analysis without a corrective action. So whatever plans we have made through our analyses should be documented in this FMEA as well. And any parties that are responsible and the dates for completion of the solutions must be documented in the assigned to and the target date column. If nobody is given a responsibility, that's exactly who will take care of it. Nobody. Always assign somebody's name and a date that they will be finished. The actual completed action should be documented in the quantitative post-action column. So this is actually what has happened and where the documentation is for what it was that was changed or corrected. And then finally, new rankings for occurrence and detection and an RPM should be calculated. Note that the severity of the failure mode never changes. If the severity in this case was death, you can't reduce the death to half death and get a lower number. Of course, if you take away the actual hazard that's presented in the risk, the severity could change because now that hazard is no longer there. Hopefully your solutions have created improvements in the process and reductions in the levels of risk.